All right, let's get a little more familiar with the switch. So this is getting to know your switch. Although a lot of these components will still apply to when you're working with the router. So by getting familiar with the switch, you will also be getting familiar with the router. The differences between one switch and another switch can really be very different. So when you go to purchase the switch, there could be lots of different options out there with lots of different price points, and it makes a huge difference, even though some of this stuff is going to be quite obvious, like the number of ports that it has, whether it has PoE or not. While others are going to be much more different in the nuances of how these switches are going to perform. So let's talk about some of the differences in the switches. Then we're going to get into the switch LED indicators in there and what the different indicators, what the different lights mean. We'll talk about the internal components, what the switch comes with, and then we'll talk about software and what software runs on the switch. And then finally, we will talk about what happens when a switch gets to the end of life, what we call the end of life, or when it's ready to retire a switch. All right, let's take a look at the differences in those switches. Switches can widely vary quite drastically, and I've seen some cheaper switches that have a lot of features, and I've seen some more expensive switches that seem to be just really overpriced. But generally speaking, you get what you pay for. Cisco is considered a premium brand. It's going to be one of the most expensive switches that are out there on the market. At least their higher end switches are going to be. But if you take a gig Cisco switch and a gig cheaper switch that's out on there that's just a consumer level product, there are differences between those. And so let's get into all of those details. So this is a Cisco class, and so we're going to be primarily focusing on Cisco, but there are other brands that function very well out there that can be cheaper. So some of these options that are out there. First of all, let's talk about port count or density. Port count is the number of ports that are on the switch. It's also considered the density because you have a certain amount of space on your rack, and how much ports do you get for that space that you're taking up on the rack. So you've got the number of ports that switch comes with. And so, a cheap switch might have just 4 ports and you could run out quickly, versus higher end switches have 48 ports, or there can even be modules where you slide in and every module you slide in has 48 ports, and so it can handle just a huge amount of ports. You've got the port speed. Does it handle 10 megabits per second, or 100, or a gigabit per second, or 10 gigabits per second? Well, we don't really see switches nowadays, new switches nowadays, really doing the 10 gigabits per second. They will support it, but they won't actually be by default that on any of the new switches. So we got the port speed. We got the backplane speed. I mentioned the difference between the cheaper switch and the Cisco expensive switch from the onset, from first glance. If you have 2 switches that are gig connections, then you think that, oh, well, they're the same, but they're not. You got the backplane speed. So a cheap switch, even though it has gig interfaces, the backplane is also a gig. So you can't have multiple computers on there all talking a gigabit per second. So with a Cisco, the backplane is generally much faster, and so you can have many devices talking that gigabit connection speed, and so the backplane makes a big difference between those less expensive and those more expensive switches. You also have half duplex and full duplex. When we're talking about switch, it's all full duplex, but whether it supports half duplex, most equipment now is going to be just full duplex. But occasionally you do plug it into some old equipment and you need to support that half duplex. You've got expandability. You've got a module system where you can slide in more modules as you grow, or there's a Stackwise which connects the different Cisco equipment together with connects the backplane, so you've got that much higher speed rather than trying to go through your 100 meg or 1 gig or 10 gig connections. You've got actual backplane to backplane, so it can be very stackable and very grow with your company as your company grows. You got auto MDIX, which we'll talk about further in the future, but that's just auto sensing whether what equipment it's being connected into and what kind of connection it needs to be, whether it's provides power to the end access equipment or not. So you may be plugging in things like access points, and that might need power, or phones, and whether it can provide power through that Ethernet connection. So that's PoE. The power requirements. So not only, some equipment will supply enough power for a few PoE devices, but not all of the ports. And some switches will provide much more power so that most of your switches or all of your ports on that switch can give power to the end devices. Copper versus fiber, whether you're going to be running fiber on your backplane or possibly even fiber to your devices. You certainly see that more so like in the data center where you have all this equipment that needs really fast connections. And so then you'll probably be more likely to use fiber there than not as likely to use fiber to the desktop. Then you've got different features that can be, so you've got managed and unmanaged switches. So the difference between managed and unmanaged switches is unmanaged is just a switch that you just plug in your equipment and the equipment communicates, and that's about all it provides. But if you got a managed switch, then you actually get onto that switch and you do programming, and really the bulk of this course is going to be talking about managed switches, because that's really where the learning curve is and what you have to learn. And there's not really much to learn with the unmanaged switches. Whether you program it versus web versus command line, Cisco, usually people gravitate towards programming it versus with the command line versus using the web interface, although there are some options for using the web interface. And other devices, other brands, they tend to go more with the web configuration. Then whether it supports layer 3, dynamic routing protocol, spanning tree protocol, VLANs, and there's a lot of other features, whether it has some sort of quality of service, whether it has jumbo frames. So a lot of different feature sets that you get with this different equipment that you may or may not need. And you always got to think about expandability. I might not need it right now, but what are my needs 1 year from now, 2 years from now, 3 years from now? And then if it offers any kind of support, a lot of your managed higher end switches have some sort of support contract, which gives you the ability to upgrade that software that's on that switch as new software and security updates come out. And then also if something goes wrong with it, then you have a contact, you have some sort of technical support that you can contact to get help with it. And when you're talking about enterprise level systems, it's going to be much more critical that you can support that equipment and call somebody if there are any issues. And there's different levels of support also. Do you want them to have a 4-hour turnaround time? So if something goes out 4 hours from there, you've got something being shipped to you, a replacement, so that way you can get up and running. And that's obviously for your more critical services. Or are you going to stretch it out and you want a day long before you get the next piece of equipment, and being down for a day for that piece of equipment is not that big of a deal. And then obviously the big one, pricing, how much this equipment cost. And I remember, I was paying a support contract for 20 grand for one of my switches. I was paying 20 grand a year for the support contract on it. So these switches can actually get very expensive as it gets more enterprise and more modules and stuff that are fit into these. So pricing is going to be big as you're choosing your switch. All right, if you're anything like me, you like to open things up and take a look on the inside. And so I've got a switch here. I took the top off the switch so we can take a view onto the inside of this thing. And just a little bit of layout. The ports, the front of the switch is right here. So that's where all the ports are at. Then we've got the 2 power supplies here. Like I say, this is a 3750. So this has 2 different power supplies and those slide in and out. We've got the fan system right here. This is the stack-wise connectors. So this is what connects 2 backplanes together. So I can actually stack these switches and have all of the backplanes connected together. Really cool technology. And then here is, dare I say, this is the backplane. This is where the data is transferring from port to port. And we call that an ASIC. ASIC is an application-specific integrated circuit. And what just that means is, essentially this is a computer. This is a computer that functions, and we can take a computer and we can put multiple ports onto a computer and we can turn it into a switch. It wouldn't be the most efficient switch because it's not designed, a computer is not designed specifically to be a switch. It's designed to do lots of things. So it may not do that function of being a switch very well. And we're certainly, at the very least, paying a lot of money for just some simplistic operations possibly. And so what an ASIC is an application-specific integrated circuit. It is a integrated circuit, so similar to it's a motherboard. It's got traces and connections, and it goes all around. And it's a computer. It's an integrated circuit, so it's a computer. It's doing processing. It's computing, and so it is a computer. A switch is a computer, although it's application specific. It's designed to do something very specific, and in this case, it's designed to do switching. So this integrated circuit is called an ASIC, or an application-specific integrated circuit. There is processing that happens on this board. It's routing traffic from one location to another, so there's a lot of processing that's happening on here. This computer this ASIC has RAM on it, so it has random access memory. That's the short-term memory that a computer has, and so we can store data on it. One of the things that gets stored on there is the running config, and we'll talk more about the running config later. We've got the NVRAM, which is the long-term data that's on here, where we want to store long-term. It's non-volatile random access memory, so that's NVRAM, non-volatile RAM. And so what just that means is that when you unplug the switch, you're going to lose information from the RAM, but the information that's stored in the NVRAM is going to stay there. So we store our config files there. And then we have flash to store bigger things like our file systems. And so if there's files and operating systems that we want to store, that's probably going to sit there in the flash. Now, one question that might come up is, well, why would we have a separate NVRAM and a separate flash? Well, in a lot of these switches, those are actually combined. So we see a lot of the switches nowadays, their NVRAM is the flash. But you may encounter at times when the NVRAM is separate from the flash. Now, as I mentioned, these are computers, or ASICs. They're ASICs. They're application-specific integrated circuits. They're computers. They are functioning as a computer. And as such, they need something to tell it what to do, how to perform, what actions to perform, especially with managed switches. So you do have an operating system that's on these switches that control the switch and give it some additional functionality. So one of those operating systems is the Cisco iOS, and that's going to be really a large focus of our CCNA as we are going, as we're working towards our CCNA, is really learning about the iOS and how the iOS functions. Now, your equipment doesn't last forever. Similar to when you buy a computer, it gets outdated over time. And in addition to being outdated with a computer, you want to make sure there are certain things that are always up to date, like your malware detection, whatever software you're using for malware detection. You want to make sure it's up to date. Since a switch does have software and it needs to be updated, and there needs to be security updates that come out for it, then we need to know how long we expect the equipment to last and how long it is supported. And so when some of this equipment is supported for a really long time. But essentially what will happen is as a particular switch or equipment starts going out of favor, or they start coming out with newer switches with newer features and faster speeds, they need to start retiring the support for the older switches. And so what they'll do is they'll go through a process of announcing an end of life for the switch. The end of life is going to have a series of dates that are going to explain, okay, at this point in time, we're going to stop supporting this. At this point in time, we're going to stop selling this. At this point in time, we're going to stop, and there'll be these different dates associated with each one of these. So just a few of the highlights. EOL means end of life. A end of sale means that they're going to stop selling it, that you can no longer buy it. And then last day of support is when you no longer will be able to either purchase or even have support on that device. There are other things that along the way that they announce of, when the last day you can actually purchase support. And so they'll have other stats with this as well. But these are the big highlights here. The EOL, the EOS, and LDOS are to announce when you should start expecting a device is not going to be supported anymore. All right, there it is, the equipment, the switch. Those are the things we're going to be getting on here and learning a lot more about the Cisco IOS. But there's lots of differences in the type of switches that you have. The switch LED indicators, we covered a lot about what those different indicators meant. We talked about internal components. I took the top off of one of the switches and showed you what it looks like on the inside and some of the components that are on the inside. We talked about the software that runs these switches, and then we talked about what happens when equipment is retired or becomes to the end of the life. Hope these videos are helping you out. If they are, can you help me out by hitting that like button?